A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. Till now, you have studied many fascinating properties of light. But there are more to come. Look at this picture. Have you ever seen this beautiful showcase exhibit which has a bright illuminated tip? We cannot see the light passing through the wire but only on the tip. What may be the reason behind this? You may have observed telecommunications cable run through a very large distance underground, but we get the signal without any time lag. How did this long communications made possible? Let's find out the answers in this session. Here, you can see a glass vessel partially filled with water. 1 spoon of milk is added into it. It is to make it colored. Remaining portion of the vessel is filled with smoke. This is to observe the path of the beam clearly. The two media involved here are water and air. A laser beam is passed into the water obliquely. You can see the path of refracted rays here. Now, we are increasing the angle of incidence gradually. As the angle of incidence increases, the angle of refraction also increases. At a particular angle of incidence, the refracted ray passes along the surface of water. That is, the surface of separation of the two media. Here, the angle of refraction becomes 90 degrees. Here, the refractions happen from the denser medium to the rarer medium. So now, we have seen that when a ray of light passes from a medium of greater optical density to that of lower optical density, at a particular angle of incidence, the angle of refraction becomes 90 degrees. This angle of incidence is called the critical angle. The critical angle will be a constant for a particular medium. Do you recall at which angle of incidence the angle of refraction became 90 degrees in the previous experiment? To be precise, it was at 48.6 degrees. So, the critical angle of water is 48.6 degrees. Now, let's continue the experiment. The angle of incidence increases beyond the critical angle. What do you observe then? Instead of getting refracted to the air medium, the light rays are getting reflected back to the same incident medium. Here, the angle of reflection is the same as the angle of incidence. So, what can we see here? If the angle of incidence is greater than the critical angle, reflection is happening instead of refraction. The rays get reflected back to the same medium internally. When a ray of light passes from a medium of higher optical density to a medium of lower optical density at an angle greater than the critical angle, the ray is reflected back to the same medium without undergoing refraction. This phenomenon is known as the total internal reflection. What are the conditions for the total internal reflection to happen? Light rays must be traveling from a denser medium to a rarer medium. The angle of incidence must be greater than the critical angle. This table shows the values of critical angle for some media. The critical angle of water is 48.6 degrees. For glass, it is 42 degrees and for diamond, it is 24.4 degrees. Now, let's consider some examples here. The figure shows a water-air interface. Light is coming from water and the angle of incidence is 55 degrees. What will happen to the incident ray? We know that the critical angle of water is 48.6 degrees. Since the angle of incidence is greater than the critical angle, light rays will reflect back to the incident medium, making the same angle 55 degrees with the normal. That is, total internal reflection happens here. Here, the same water-air interface, but the angle of incidence is changed to 48.6 degrees. We know that the critical angle of water is 48.6 degrees, which is the angle of incidence here. So, the light ray will travel through the interface of the media. That is, the angle of refraction is 90 degrees here. Here, the figure shows a glass-air interface. Light is coming from glass and the angle of incidence is 28 degrees. We know that the critical angle of glass is 42 degrees. Since the angle of incidence is lesser than the critical angle, the rays will undergo normal refraction. Glass has a higher optical density than the air. That is, light rays are going from denser medium to the rarer medium. Therefore, the rays deviate away from the normal. We have seen how total internal reflection is happening. Now, let's see some of the practical applications of this phenomenon. In the telecommunication process, signal has to be transmitted through a very large distance without any loss of intensity. For this, optical fiber cables or OFCs are used. Optical fiber cables works based on the principle of total internal reflection. In this figure, you can see the structure of an OFC. The innermost layer is called the core. Electromagnetic signals are transmitted from a source to the receiving device through the core. Cladding is the layer just above the core and serves as a boundary for signals. Core has a greater optical density than the cladding. The signals are entered into the core in such a way that the angle of incidence is greater than the critical angle of the core. Therefore, the signals undergo total internal reflection and are reflected back to the core repeatedly. So, by repeated internal reflections, the signal reaches the receiving device without any loss in the intensity. Total internal reflections has applications in medical field also. Have you ever heard of a medical examination technique called endoscopy? Endoscopy is a procedure where organs inside our body are looked at using an instrument called endoscope. This endoscope uses optical fiber cables to produce an internal image of the body. A bunch of optical fibers are inserted to the body through the mouth. Some carry light into the body and some carry light reflected off the internal body surface back out. This made possible by total internal reflection. Now, you may have understood how that illuminated showcase exhibit works. Light undergoes total internal reflection through the long wire and passes out through the tip. Total internal reflection is one of the important and amazing properties of light. So, in this session, we have studied total internal reflection and its major applications in various fields.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS the Learning App.